In this video, we're going to talk about graphing piecewise functions. Piecewise functions are functions that have been stitched together and given some restrictions. For example, this is a piecewise function. And what this is saying is that if x is less than 6, use this top function. If x equals 6, I want you to use this one. If x is greater than 6, I want you to use this one. When I'm graphing these, the first thing I like to do is I like to look at what this critical number is, what they're talking about. And in this case, it's 6. And so I'm going to go over to 6, and I'm going to kind of give myself a dashed line there just for reference. It's not part of the graph. It's just telling me that that's where my graphs are going to change. So I'm going to start this by graphing this first function. So that's slope-intercept form. My intercept is at -1. My slope is 1, so I go up 1 over 1. And then I take my handy-dandy ruler here and put it in place. And I go ahead and draw my line. And I'm going to stop just before I get to 6. Because at 6, this says, top function says x can't be 6. It can only be less than 6. So at 6, I'm going to put a hole. Because it can't be, you can't plug 6 into this first one. So then if I go to the second function, it says that when x does equal 6, I want to equal 2. So I put a dot. The third function says that when x is greater than 6, I want you to use -x plus 1. All right, so I got to graph that. Well, if I use just slope-intercept form, I've got +1 right there for my intercept, and down 1 over 1. I'm going to take my ruler and I'm going to draw the line, but I'm only going to draw it to the right of 6 because I know that x can't be less than 6. It has to be greater than 6. But once again, it also cannot equal 6, so I'm going to put a hole right there. Throw some arrows on the end so we know that it goes on forever. We're pretty happy with that piecewise function. Let's do one more. Okay, so this one says if x is less than or equal to 6, use that. If it's 6 is less than x is less than or equal to 8, use that. And if it's greater than 8. Okay, so this one I'm actually going to have more than one dotted line just to set up my parameters. So I'm going to go over to 6. And I'm going to draw a dotted line there just to give me a reference. I'm going to zoom way out because why not? So I'm going to draw my dotted line at 6. And then I'm going to draw another dotted line at 8 because I know things happen at 6 and 8. So it says if x is less than 6, y equals -3. And a lot of people forget how to graph that. Well, y equals -3 is pretty easy. It's just a horizontal line. So I'm going to draw my line at y equals 3. Oops, -3. I'm going to draw my line at y equals -3 till just before I hit 6. And then I have to look. Well, this says that x is less than or equal to. So it can be equal to. So I'm going to make a filled in dot at 6. Now, The middle function here says that if it's between 6 and 8, use the function y equals x. Y equals x is another one sometimes people have a hard time with, but you have to remember that if there's not a y-intercept, if there is no plus b, it's 0. So it goes to the origin, and then the slope is 1, so it goes up 1 over 1. And this is only going to occur between 6 and 8. So I'm going to take my little ruler, and then between 6 and 8, I'm going to draw my line. And then I have to look at the ends. So at 6, it can't be or equal to, so it's an open circle. At 8, it is or equal to, so it's going to be a closed circle. And the last one says use y equals negative 1/5 x minus 3 if it's greater than 8. Okay, so minus 3 and then negative 1/5. So down 1 over 5. 2, 3, 4, 5. No, let's see. 1, 2, 3. That's 4, 5. I use my ruler again. And this one is only after 8. So it's greater than 8. So it's going to be that. And then it's not or equal to, so I put an open circle. Throw arrows on the end, and I've graphed this piecewise function. It's basically graphing 3 things and just setting up some restrictions on it.